Radioscope, the National Science Magazine program.
Science and technology hold the key to the progress and development of any nation. It has always been an integral part of Indian culture. Natural philosophy, as it was termed in those ancient times, was pursued vigorously at institutions of higher learning. The Indian Renaissance, which coincided with our independence struggle at the dawn of 1900s, witnessed great strides made by Indian scientists in the fields of science, astronomy, healthcare, environment, medicine, defense, and whatnot. With that premise, Radioscope during the next 30 minutes will take you all on a journey of scientific understanding of nature, unfurling recent developments in the field of science and technology.
Before we start flipping over the pages of the magazine, here is a couple of wow tidbits. The world's largest amphibian is a giant salamander. It can grow up to 5 feet in length. Great, right? Now, another fun tidbit. The hottest planet in the solar system is Venus, with an estimated surface temperature of 864 degrees Fahrenheit, corresponds to 462 degrees Celsius. Now, an interview with Professor Lydia, Head of Department of Mechatronics, Sri Krishna College of Engineering, Coimbatore, on drones and their various applications in multifarious fields. She is being interviewed by Shri R. Murali, Head of Programs, All India Radio, Coimbatore. This is a contribution of Akashvani, Coimbatore.
Hello listeners. It's really an imagination, especially for childhood. Aircraft is always a fascinating one, especially an unmanned aircraft. Now the dream has become reality. We are able to see UAV, that is drones, unmanned aviation vehicle. Drones, as they call, it is a fascinating one. Now, almost in all fields, in agriculture, surveillance, the militaries of the world, they have these drones. Actually, we need a proper introduction for drones. What are the drones and what are its functions?
Drones, they're also known as unmanned aerial vehicles or unmanned aircraft systems. They're basically remotely operated flying machines that do not require a human pilot on board. They can be controlled remotely by a pilot or can operate autonomously through pre-programmed flight paths. The important parts of a drone are the frame, which is the main structure of the drone. Then you have motors, multiple electric motors that power the propellers and generate lift. You have electronic speed controllers which control the motors, adjusting the rotation speed of the propellers to maintain stability and control. It also has a flight controller, which is the brain of the drone, processes sensor data, user inputs to stabilize and control the drone movement. We have battery, radio, transmitter and receiver, propeller guards, GPS module, which helps the drone to obtain its location, provide features like position hold, return to home, the waypoint navigation. It also has inertial measurement unit, camera, onboard storage, etc. The main utility of drones is it has been used in aerial photography, surveillance and security, agriculture, especially in collecting data on crop health, soil moisture, pest detection, helping farmers optimize their operations. It has also been used in search and rescue missions, in delivery services, and also for environmental monitoring, for infrastructure inspection, and disaster response. Drones come in various types based on their design and application. We have multi-rotor drones, we have fixed-wing drones, single-rotor helicopters, and hybrid drones.
In what way these drones are helpful in agriculture, especially the farmers?
In agriculture, very specially, the main things which the farmer does is the sowing and after taking care of the plants. One of the main thing is application of pesticides, insecticides, fertilizers, And many of these products have been harmful for the farmer's health even. And there has been complaints of excessive use of pesticides, sometimes use of pesticides in rainy seasons, which may result in the pesticides being just washed off into the nearby water bodies, so on and so forth. So one very best example where we can use drone is for application of pesticides, so that when the farm is a big farm, or even on the innermost sites of the land, which is inaccessible for a farmer to go, the drones can just fly and apply where it is needed the most. In the drones, we can attach cameras which can help in detection of crop health. If a particular region of the farmland is infested heavily, we can use the assistance of drone to spray the pesticides or insecticides in that particular zone. So careful, optimized application of pesticides, application of fertilizers is possible using drone. And also monitoring of crop health. Maybe if there is a pest or any worm affecting the farmland, these periodic images which the drones can take and pass it on to us can help us to identify whether there is any pest attack. So the monitoring of crop health, we can identify it with the color of the leaves, the shape of the leaves, holes in the leaves. There are different images that can help us to understand whether the crop is healthy or it is starting to be affected by any pest. The constant monitoring of crop health is possible. Apart from that, the irrigation schedule, the measurement of soil moisture, measurement of nutrient contents in the soil, all those things can also be sensed and stored in a drone, which can help the farmer to plan accordingly. So overall, monitoring crop health, monitoring soil moisture, monitoring pest detection, and many other ways, the farmers can be helped by suitable application of drones, because it saves time, it saves manpower. It does a lot of, the utility of drones is extremely high because it's time efficient. A lot of farmland a single farmer can cover if they hire a drone or if they use a drone for a single day. And it is safe too, because as we said, the usage of pesticides and other things can be harmful when they inhale it. Adds to the safety of the individual farmer. Drones can be used for data collection analysis so that we can apply predictive algorithms. We can predict the rainfall and then plan your pesticide application accordingly. We can predict the occurrence of pesticides, pests. We can predict the occurrence of different things that can impair the health of the crop.
Drones are very much useful in surveillance. In what way drones are useful and how they are useful? Kindly tell us.
Drones play a major role, as you said, in surveillance and security. And as we began, it is unmanned aerial vehicle where it doesn't need a human pilot to run it. You can control it by remote. So when it comes to surveillance and security, there are countries which are facing border issues. So there is a border patrol, and there are many soldiers who have their lives at risk. And there are ranges and terrain which are not very safe for human beings to travel. And these are the places where drones come very handy, because I told you the different parts of the drone, where it is equipped with a camera, it is equipped with several measuring instruments so that it can measure the movement, it can trace the movement of enemies, especially in border patrol. Drones play a vital role.
What would be the future of drones? There are certain science fictions about drones totally becoming a replacement of men on move, actually.
For every time a new technology comes in, people always are afraid that it will do the work of man. But the truth is, definitely it's going to do some of our work. But what will be required from humankind will be a more skilled, a more trained, people with more trained skill sets. We may have a drone army, we may have a drone doing work in the agriculture, doing work in many fields. But then to operate all these drones, we need licensed people who know to control it, who know to maneuver it and to control its path, navigation, everything. So though one set of work will certainly be, which we commonly do, will certainly be replaced by drones, but still humankind and we ourselves will be required to have a higher skill set to handle it. Drones, because of its wide range of applications, are versatile, they are agile, and they have the ability to access hard-to-reach areas. Leave alone surveillance, security, and agriculture, drones are extensively used in photography, in filmmaking industries, to capture stunning aerial shots and footage. So drones have been helpful in search and rescue operations, especially in disaster-affected areas, where to locate missing persons. So when we have earthquakes, floods, when nature takes a toll on humankind, and then we stand helpless, drones have come to rescue because they're equipped with cameras, with thermal imaging sensors, so they can be deployed in search and rescue missions. They are being used even in delivery services, and drones have also been helpful in environmental monitoring. So how I see is, most of the works which humankind has found it difficult to do, drones will make it much easier.
India is recognized globally for its scientific rigor and potential. India was able to gain pace in scientific discovery only after independence. Getting back the reins of democracy and planning the years ahead to regain our prosperity encouraged people to work towards scientific and technological advancements. In all these years, India witnessed a massive shift in different fields of science and technology by strategically aligning its skills and resources. We bring to you a quick recapitulation of the accomplishments of India in the field of science and technology post-independence and the developments we are progressing towards. The first ever 5-year plan draft was presented in July 1951, which had a dedicated chapter on scientific and industrial research. Being the first plan, it prioritized laying the foundation of scientific research in the country and largely focused on initiatives for building or enhancing national laboratories and research centers. After independence, regaining control of agriculture production was a task. Research about the crop yield potential of locations across the country, irrigation systems, effective fertilizers, pesticides, power sources, agricultural equipment was lacking. Government prioritized scientific research for advancing agriculture. This led to the Green Revolution during 1957 to 1967. This enabled India's agrarian economy, which was on the brink of collapse in 1947, to improve steadily. This revolution made us self-reliant, as we traveled the distance from being an importer of food grains to one producing it in surplus. India's contribution to the science of space is immense. The Indian Space Research Organization, ISRO, was established in 1969 to serve as India's national space agency. The first ever Indian satellite was the Aryabhatta, which was designed and manufactured in India and was launched on the 19th April 1975. ISRO developed Aryabhatta to execute X-ray, astronomy, aeronomy, and solar physics. India successfully developed strategic missile systems in the 1980s with successful testing of Agni in 1989. Eventually, Indian scientists were able to demonstrate abilities such as re-entry, maneuvering range, control, guidance, two-stage propulsion, and stage separation. Since then, India has created, tested, operationalized several missile systems. The Agni became a series of missiles, with the latest one being Agni 5. DNA fingerprinting in India came into existence in 1988 when Council of Scientific and Industrial Research, Center for Cellular and Molecular Biology scientists developed the technique and made it available for use, making India the third country to develop its own DNA fingerprinting probe. On 11th May 1998, India successfully tested 5 nuclear bombs underground in Pokhran, Rajasthan. These tests were titled Pokhran 2 in order to facilitate the technological achievement of an emerging democracy. This day was named National Technology Day by the then Prime Minister of India, Shri Atal Bihari Vajpayee. Since then, it is observed each year. Chandrayaan-1 was India's first ever mission to the moon, launched on 22nd October 2008 from Sriharikota, Andhra Pradesh. The spacecraft hovered around the moon to deliver chemical, photogeologic and mineralogical mapping to ISRO. India accounted for around 60% of the global cases of polio in 1994. A dedicated campaign to vaccinate every child by the government enabled us to become polio-free within 2 decades. India received the polio-free certification from World Health Organization (WHO) on 27th March 2014. This immunization drive was a success because of strong policy, committed healthcare professionals, frontline and community workers. A large part of this campaign was the education of those hesitant to get vaccinated in backward and rural areas of the country by increasing awareness about its safety and benefits. Mars Orbiter Mission, also known as Mangalyaan, was a historic first for India, its first ever interplanetary mission. Mangalyaan marked India's place in the field of space exploration. Launched on 5th November 2013, Mangalyaan studied Mars topography, morphology, mineralogy and atmosphere. Apart from the scientific breakthroughs, Mars Orbiter mission is also lauded for its cost effectiveness. India was at the forefront of the vaccine development research, eventually becoming one of the largest manufacturers and exporters of COVID-19 vaccines. As of end 2021, India supplied over 7 crore COVID-19 vaccine doses to more than 90 countries. Further, the scale of India's vaccination drive has been unprecedented. As we continue to evolve and innovate, the aim is to maintain the pace of development in science and technology, along with ensuring global recognition and exposure.
Next is an interview on cold atoms with Professor P. Muruganandham, Department of Physics, Bharatidasan University, Tiruchi. He is being interviewed by R. Rasha Shanaz, a research scholar. This is a contribution of Akashvani, Tiruchirappalli.
To discuss about cold atoms, we have with us today Professor P. Muruganandham. He is a renowned computational physicist who has been researching cold atoms and nonlinear dynamics and machine learning for more than 20 years, and he has collaborated with several Indian and international research teams on around 100 scientific publications. Thank you for joining us today, Professor. To kick off our interview today, could you give us, our listeners, a brief introduction to the field of cold atoms and what exactly are Bose-Einstein condensates?
Thank you, Rasha. Cold atoms are atoms that are maintained temperature close to absolute zero. Means it is minus 273.15 degrees Celsius or minus 459.67 degree Fahrenheit. At these temperatures, atoms behave very unusually and exhibit many exotic properties. Normally, we classify particles into 2 main classes based on their spin. The spin is an intrinsic property of atoms or particles like charge and mass. If the spin is a whole number, then we call the particles as fermions. If it is not a whole number, that means 1/2 of an integer, then they are boson. So we all might have come across the Pauli's exclusion principle. Fermions obey Pauli's exclusion principle. The Pauli's exclusion principle restricts more than 2 fermions from occupying same quantum state. Whereas in the case of boson, there is no such restrictions. You can accommodate as many as bosons in a single quantum state. At high temperatures, particles in a gas behaves like a billiard balls, and they have thermal energy which is proportional to the temperature in Kelvin. What happens when reduce the temperature to a point where this thermal energy goes to zero? So each particle is associated with a characteristic length known as de Broglie wavelength. this wavelength is nothing but the uncertainty of the position of the particle due to thermal momentum. And this wavelength is inversely proportional to the square root of the temperature and also square root of the mass. This de Broglie wavelength describes the spatial extent of the atom. As temperature approaches to close to zero, this length becomes large enough to overlap with that of the neighbors. Consequently, the particles atoms lose their individuality and behave collectively as a single entity. Albert Einstein predicted this behavior in non-interacting particles based on Satyendranath Bose's idea in the 20s. Later, it was known as BoseEinstein Condensation. However, it took nearly 77 years to realize BoseEinstein condensate experimentally. In 1995, 3 individuals, namely Eric Cornell, Carl Weyman, and Wolfgang Ketterle, along with their co-workers, achieved BEC experimentally, and these people are awarded Nobel Prize in 2001 for their achievement.
That sounds truly intriguing. So, what are the unique properties and applications of these Bose-Einstein condensates that make them so interesting for the researchers currently?
Well, Bose-Einstein condensates are unique state of matter that exhibit many fascinating properties. For instance, coherence. What is coherence? So, Bose-Einstein condensate are coherent states, meaning that all the particles in the condensate are in the same quantum state. We can distinguish this coherent state from ordinary matter, similar to how we distinguish lasers from ordinary light. This coherence is responsible for several unusual properties such as superconductivity and superfluidity. Both superconductor and superfluids are Bose-Einstein condensate. However, we can't study them well because we cannot describe the interaction in the system. In the Bose-Einstein condensates, we can control all the interactions from outside because we are creating it in the laboratory. Okay, and the second one is quantum tunneling. So BECs can tunnel through barriers that would be impossible for classical particles to overcome. This property has been used to create new types of sensor. The third one we can think of quantum entanglement. See, the Bose-Einstein condensates can be entangled with each other. Quantum entanglement is a physical phenomenon that occurs when two or more particles are linked together in such a way that they share the same quantum state, even they are separated by a large distance. It has no counterpart in classical physics and it challenges our understanding of the nature of reality. This property has potential applications in computing, communication and teleportation. Finally, you can think of quantum simulations, where these ultra-cold quantum gases can be used to simulate many condensed matter, many body systems, like artificial solids.
Wow, it seems like they hold a huge potential to be the experimental tables to study so many other quantum systems which would otherwise be difficult to study. And it's fascinating to hear how BECs can open doors to so many groundbreaking technologies. Now, can you tell us about some of the most significant breakthroughs or discoveries in this field of cold atoms?
Yeah, there are many. First thing is we need supreme accuracy in time measurement. So BECs are used to develop such atomic clocks. So we can develop atomic clocks. Even in India also they are developing some atomic clocks based on BEC. The ISER Pune, they have been setting up a strontium clock. And another interesting thing is an atom interferometer is a tool to make precise measurements of gravitational acceleration, inertial sensing, magnetic field gradients and fundamental physical constants. So, and further, we have Bose-Einstein condensers of polar atoms, means the atoms which have dipole, long-range dipole-dipole interaction. So that also exhibit many unusual properties. Quite recently, there are spin-orbit coupled Bose-Einstein condensates. This spin-orbit coupling is very crucial for many important condensed matter phenomena. It normally requires electric field of the order of trillion volts, which is unimaginably high. We cannot even reach that kind of voltage to achieve significant spin-orbit coupling in atoms. Instead, we can use BEC to synthetically generate or simulate the spin-orbit coupling. So this has many applications, including spintronics, spin Hall effect, topological insulators. And there are continuous Bose-Einstein condensation achieved recently, which has high flux, high coherence of matter, and you can produce a continuous beam of Bose-Einstein condensation. It's a coherent beam of atom, a quantum matter. There are also proposals to study condensates of quasi-particles. The quasi-particles are not real particles. They are excitations within solids. So they are an effective particles. And it's also good to know because these particles have very little mass. And because we know that we can increase the de Broglie wavelength by reducing the mass also. Not only the temperature, by reducing the mass also. So these quasi-particles are very good candidates for Bose-Einstein condensate, which we can realize even in room temperature.
That was Radioscope, the national science magazine, and we hope you not only enjoyed our magazine, but gained some insights into the world of science too. Scripted and produced by Ramaswami Sudarshan with inputs from Akashvani, Coimbatore and Tiruchirappalli. This program was a contribution of Akashvani, Chennai.